Okay, so in the previous session we already solved the multi-species problem, right? So up to the pre-processing state. So the problem is around taking a 2000 iteration to converged. So it is not possible to show all the convergence process. So I just double tap on that particular file. So the file get loaded within a minute. And this video is completely for the CFD post. Okay, so in the previous session we discussed about the boundary condition creation and then wall condition application. I mean, like how to define that velocity and then boundary conditions. That's all. Okay, like the solution methods and then residuals. These things we already discussed in our previous sessions. So now we have two sets, that is setup and solution, which is already it's a solved file. Okay. So what we are looking for is CFD post. So for that we need a post processing environment, that is results. So right now we use a standalone component system. So when I am looking for that results in the component system, you may have a entity that is called results. So just drag and drop the result to the solution. So what happened here is the entire solution data is transferred to the result entities, that is post processing. So just double tap on it, the CFD post will get started. Okay, so this is our car carriage. So you know about the boundary conditions. This is our inlet and this is our outlet, and there is a combustion happened on the front side of the car. Due to the combustion, now we are looking for that temperature distribution and then velocity at the inlet and pressure drop. So we can looking for a lot of results over here. Let's say one by one. We'll start from a basic results. Okay. So outline. I mean, right now we have one outline view. Okay. So all the entities we have in the line. So if you want to view the surface, you can just enable this things like front wall, you can just enable that, or car. Okay, so by default you will have a wireframe diagram. Okay, so the first thing is I want to view the temperature difference in the walls. So the wall is made up of concrete, right? So which is having a thickness of 0.15 meters. Okay. So for that, you'll have an option called location. So just click on location. So here you'll have a lot of options. We'll discuss about all the options in our upcoming session. For now, I choose a option called surface group. Okay, so just click on surface group. So name it as a walls. So my interest is to view the temperature difference at the walls. So I'll give the name as walls and click on OK. So as soon as I click on that, it asks me to select the location. So which location you want to view the results. So I want to view the results on the walls, that is ceiling, so at the top face, at the bottom face, and as well as this walls. So you can't select this wall and this wall, because this wall we assigned as a symmetrical one and this we assumed as an inlet one. Okay, so except this and this, you can select all other walls, so including that inlet jet also, so jet wall also. So how can I choose a multiple section? Because when you drag and drop this option, you have the option to choose any one locations. But if you want to choose multiple locations, so you can click on the three dots over here. So just click this. Okay, so I just click on this. So the location selector may be enlarged. So from here itself, I want to choose all the wall location, which is wall ceiling and then wall floor. So just make sure you are pressing control, wall floor and jet wall housing and then wall outer. So I want to choose the fourth thing. Okay, so once you choose that, just click on OK. Now the multiple selections will be selected. Okay, and what you are looking for? So I am looking for the temperature changes. So go to the colors option. So the colors will shows the temperature difference, right? So go to the colors. By default it's set to constant. Okay, so I want a variable. So now my variable is, so in the variable selection by default it's set to pressure. So just drag and drop, you'll have a varieties of options like CO2 mass fraction, density, eddy velocity, and inner wall temperature, like that. I'll choose temperature. So we are looking for temperature, and either you can use global or local settings. Both the results will show in the same manner, so there is nothing difference between them. So just click on apply. You may observe that, so there will be a maximum temperature at this point because the combustion has happened over here. The heat is around 1200 Kelvin, so initially we applied, but at the wall region it's around 3.92 E power 02. Like if you want to change the scientific value to the normal one, you have the option. See, how can I change that? Like in the default legend view, so just click on that option. So just choose this, double tap on it. So go to the appearance, so it may changes this appearance. So right now the precision is set to 3, so I need a single precision value like 1. So the precision means the value after the points. Okay, so right now it's set to 3, so that is why it shows that 2.931. So after the point it shows the 3 values. So if you set 1, it doesn't show, it only shows a 1 value at the point, after the point. Okay, and also I want to shift over from scientific to fixed one. I don't want the scientific terms. So once you define that, just click on apply. You may get a value like this. See, if you give the precision as 0, you don't have any other values beyond the point. Okay, so if you give 2, the 2 values will be shown over here. So it will be much easier to view the results. So to generate a results, the picture is most important thing. So how can you make it as a screenshot, sir? Either you can make it as a screenshot by pressing Windows key and print screen. So that screenshot will be saved in your pictures folder. But how can you take a screenshot by using CFD post? So there will be entities which is available over here. See, nearby the animation tool. So just click on that particular tool. So currently set the view by using that arbitrary option, and click on this. So it asks you to name the figure. So I don't want to name that. I'll leave to figure number 1. So I'll say click on OK. So you may notice that in the report a picture 1 is added. So the current view is taken as a screenshot. Okay. So that will be available when we generate the results, reports. Okay. So the figure 1 is created, so it shows the temperature variation around all the walls. Okay, fine. So the next thing is we are looking for that temperature variation around the surfaces. Okay, so first I will just turn off that walls. Maybe it will give you a clear idea. So my idea is, my thing is, I want to view the temperature variation. So over this directions, so like in this direction and in this direction throughout a plane. So for that I need to first create a plane. To create a perpendicular plane, you can go to the location. You may have the option called isosurface. Just click on that. So if you want to give the name, you can. So I'll give the name as XYZ plane. So once you give the name and say click on OK, so a detailed of XY plane is created. So in the geometry, which location? So by default I'll choose all domain, and the variable is, so now my variable is Z. So I want to create a plane which is perpendicular to the y-axis. So that is why I am choosing the variable as y. So once you choose that, how much it should be offset from that y direction. So I want to create a midplane around this car like this. So I'll give a default value that is 9. So it may be vary with respect to the case. In my case it's 9 meters, and I'll just give the value as 9. And if you want to change the color, you can go to the colors option. So right now it's set to use plot variables. So I'll change to variable. So I'm looking for the temperature variation. So the variable is temperature. Okay. So you can change the global to local. I'll leave to global, and say click on apply. You may notice that surface will be generated like this. Okay. So when you zoom in the region very closer, the temperature distribution, you may observe how it's actually released from that combustion region. Okay. So if you want to move this spline in this direction, in y direction, like this and this, to and flow motion, you can also animate the spline. How can I? So go to the animation option. So in the animation, you have the XY plane. Just choose that. So give the frame rate as maybe 500 or 570 something. So if you increase the frame rate, it will be it will move much slower, or else it may move very faster. Okay, you can't observe the temperature variation around the region. Okay, so once you set down that, just click on play. Now you may observe that the plane is moved in this direction. So once it completely hits this face, that is inlet, it may bring back to the another end. So over the session, you may observe that how the temperature is actually changed. Okay, fine. So if you want to stop the animation, just click over here. So don't click here itself. So it may corrupts the software. Okay, just click over here. Once the animation is stopped, just close it anyways. Okay. So now we created a plane, and we just observe how the temperature is changes around the y-axis, y direction. Okay. So I just turn off this XY plane also. And the next thing is we are looking for that CO2 mass fraction. CO2 mass fraction. So in the initial stage, like in the previous, pre-processing stage, we give the species as we have so many gases over here, like oxygen, and then vapor H2O, and then nitrogen and carbon dioxide. So many gases around this garbage. So I am only looking for what are the percentage of the CO2 is presented in this region. So I want to observe that CO2 concentration. Okay. So for that, first I will change the color of the car. So if you want to change the color, or else if you want to view the car outer surface, so this is the wall of the car, just click over here. So it will be, right now it's in the blue color. So if you want to change the color, just double tap. The color mode is constant, so just click the three dots. We'll have varieties of colors. I'll choose dark yellow, will be much brighter, and say click on apply. Now the color is changed. Okay. So once you change the color, again you can go to the surface, ISO surface. Either if you want to name anything you can, but I will leave to ISO surface 1. And my variable is, this time I'll choose CO2 mass fraction, and give the fraction value for a better view, because 0.001, and click on apply. Okay, right now it shows in a blue color, so I want to change the color constant. I'll choose a color of light brown color. Okay, and say apply. Okay, now the color is get changed. You may observe that how the CO2 is actually spreaded around the area, like the garbage area. Okay, so apart from that, you have a varieties of gases like NO2, and then O2, oxygen. So you can change the variable from here itself, like, so instead of choosing CO2, you can choose some other variables. So once it is created, just make it as another screenshot. So this may take place in our report. So to make the screenshot, just click over here and name it as a figure 2 and say OK. Now the figure 2 is generated. Just make sure it's take place in that report or not. Okay. So also take this screenshot also. So this variation screenshot, maybe it's figure 2. I mean figure 3. So I'll turn off this. So you may turn on or turn off the results anytime. If you want to view the all result, you can turn on or turn off it. So all the results you have created over here will be listed over in this user location and plots. Okay. So now we viewed that CO2 mass fractions, right? So and then we can view the velocity changes. So actually, it's in this case it's the inlet. So this is the inlet. So we have a jet pump over here, and this is our outlet. So what happened here is the inlet air is sucked from this region and blow over the car region, and the cold air and hot air will mix together and will get out from this region throughout this outlet. Okay, so we can view the velocity variation using streamlines. I just click on the streamline. So streamline number 1. So if you want to change the streamline to velocity or some other, okay, so I'll give the name it as a velocity streamline 1 and click on OK. So the type is 3D streamlines. So we don't need to change that. Where it's actually start from. So it's actually start from the inlet. That is inlet fresh air. Okay, from this region the streamline is actually started, and my variable is velocity. If you want to view the some other things, you can change from here itself. So once you click that, so I'll change the plots to 25 to 100 and click on apply. Okay, now the streamlines is generated. So from the color variation you can observe that we have a maximum velocity at this region, because there will be a momentum which is about the z-axis, right? So here we have the jet pump. So that jet pump sucks the air from this region and blows over here. So that is why we have a higher velocity over here. So this is what we expected also. And also you have a higher velocity. So it's not a higher velocity, we have higher velocity in this region. It's much higher than compared to this region. Okay. So if you want a more detailed one, more detailed thing. Okay. So you can also increase as that point regions, like from 100 to 200 and click on apply. So there will be a much higher streams over here. So you can easily animate this also. So to animate this, you can just go to that animation and choose the streamline, that is velocity streamline 1, and maybe you can give a very slow frame rate, that is around 600, and just click on play. Okay, now the ball size is much bigger. So if you want a better animation, probably I will just stop the animation, go to the options, okay, so in the option right now the symbol size is 0.1. I'll reduce the symbol size to 0.5 and click on OK, and just select this and say play the animation. So it will be much easier to get them. You may have a better animation. Also you can save the animation file. So just stop this. So you'll have the option, so just click to save the animation. So now you need to choose which location you want to save the animation. Maybe I'll choose desktop. So which format? So I want to save in the MP4. Okay. And click on save and say play. Okay, so I'll choose loop. So repeat forever. Maybe you can choose some other format also. Okay. So at the first time it will be very slower because it is actually converted into a movie, right? So at the next time it will be much faster. So we have to wait for one single time. So this animation will be saved as a video file in the specific location. So it may require a lot of graphics. So just don't try. So if you have so only just try if you have a dedicated graphics. So otherwise don't try it. Okay. So just close it. And if you are not looking for that, just go to the desktop. You may have the file also. So in which location we have saved that video, so that will be saved in that AVI format. Okay, so this is a streamline method. So if you don't want, so if you can take it as a screenshot also. I'll make it as a screenshot number 4. Okay, so that will be saved in here itself. So I just turned off it. And next, so we're gonna view the volume render. Okay, so how the COV2 is propagated. So for that, go to the volume render. If you want to change the volume render name, so you can change that. My variable is CO2 mass fraction, and the range is global. So just click on apply. See, you may observe there will be a light blue color. So in this region, so it may not be clearly visible. So what I'm going to do here is go to the files and okay, so edit options. So it's a CFD option. So go to the viewer. So in the viewer I will change the background color. So the background color type is solid. I'll choose a background of white, and Ansys logo is also white, and apply. Click on OK. Now it will be much easier to view the results, right? You may have a better view. How the CO2 is actually spreaded around this region. This is the one type of method to view the results, like volume render. Either you can use the isosurface method or else you can use this method also. Okay, so the next thing. So how can I view the temperature difference in terms of graphs, sir? So that will be the next thing. So any graphs in CFD terms, in CFD post, if you want to view anything in a graph, so obviously you need a line segments. Okay, so in which region you want to view the temperature results, so just draw a line on that region and you can use that particular line to view the temperature results. Okay, so how can I create a line? So go to the same location option. Here you will have an option to create a line. So line, click on OK. So you have to give 2 points. So we already draw a line in that AutoCAD, right? So that polar coordinate system, I mean not polar coordinates, that is absolute coordinate system. So the first point and second point you need to enter, so a line will be generated, right? So similarly, I'll give a standard factor, that is 18 and 3 and 2, okay, not 1 and 2, and here it's 18 and 18 and 2. Okay. So once you click on that, just click on apply. You may be observe a line will be generated from this end to this end. So if you change this value, the line direction will be, and then length will be changed. Okay. So from where it's actually measured is from this coordinate system. So this is the origin point. So we just give the x value and y value and z value. Okay. So by using this line, I'm looking for that charts, that is temperature, profile, what are the temperature has actually changed over here. So I just turn off the another thing, that is volume render. So where we have the volume render, I just turn off it. Okay. So to create a chart, you may have the entities. So here itself. So just click on that. So I just click over here. So the name is chart 1. So you can give any name. So maybe I'll give I'll leave to chart 1. In the title, just temperature profile of Y. Okay. So that in data series, so the name may be okay. So the location, so from which the charts is actually started. So at the line. So the line one just we created, right? So just choose that line. So from this, the calculation is actually begins. Okay. And what is the value for the x-axis and y-axis? So this is y and this is x, right? So in x, I'll choose a variable as y. Okay, not y. Yep. And in x, the variable is temperature. So we are looking for the temperature variation, right? So that is why temperature. Fine. So once you click on that, just click on apply. You may have the temperature variation data around the y. Okay. So this value you may observe. So this is y is nothing but the line we draw. Okay. So in the picture, the line is actually parallel to the y-axis. That is started from 2 and having a length of, according to the coordinate, it starts from the value of 2 and end with the value of 18. So that means the length of the line is 16. Okay. So throughout the 16 at the length, so at the starting point of the line, so around 3 meters, so the temperature is 320. So around 4 meters, the temperature is which is less than 320. So at the length of 6, so the temperature is around 330 or 345 like this. So the peak temperature is, it's actually observed over the region of 6.5. So 6.5 meters. Maybe the 6.5 meters which is nearby that combustion region. So the car front end, right? So throughout it the temperature is varies like this. Okay, sir, I want a smooth curve. So right now we don't have a smooth curve. So only we have a 20 values. So to increase that, you may go to the lines again, the lines. So right now the samples is set to 10. So that is why we only have a 10 sets of values. So I may increase the value to 20 and say apply. You may have a 20 values. So if I give a value of 50 samples, the 50 markings will be happened over the curve. Say apply. Okay. So now you can clearly observe that from this point. Okay, so if I draw a line from this region, so it's around 6.5. Okay, so 6.5 there will be a maximum temperature. So that surely happens around this region. Okay, so if I go to this view, so the 6 is around this region. Okay, so it's 2 and it's 18. So 2, 3 and 4, 5 and 6 is around here. So that is why we have a maximum temperature over this region. Okay. So the next thing is, so I'll just go to the chart view. Okay, so we discussed different locations. So how can I create a volume render and then creation of lines by using the lines? How can I create a chart? And one more option is also available in the CFD post. So that is very super cool option. Okay, so to calculate that mass flows and everything. So you have an option called calculator. So you have 3 calculators, that is function calculator and then micro calculator and mesh calculator. So we use these calculators for different purpose, but in this problem we'll use the function calculator. How can you use a function calculator and calculate a basic function related things? So I'll just click on that. So in that outline you can shift over to calculator option also and choose whatever the calculator you need. Okay. So in these entities you have 3 different sets of things like functions, location and cases. Okay. So in the function things, so I want to calculate. So right now I want to calculate the volume integrity. So of which factor? So that is CO2. So how much volume, how much CO2 is actually presented inside that carriage. So that is what I am looking for. So you can choose the function as maybe that is volume integrity, or else volume average also you can calculate. So in which location you want to calculate? So I want to calculate in that fluid main carriage. So that is the fluid which is around in the carriage, and which variable, so either pressure or that. So I want to view the CO2 mass fraction. So once you choose these things, just click on calculate. So you may have the value. So by simply you can calculate the volume integral of the CO2 mass fraction. So that is around 0.90167. So you can also view the results in the Fluent itself also. CFD also have the option to calculate these things. So in the meanwhile, so if you want to view the volume average, so just shift over the function and say calculate. You may get the volume average of the CO2. Okay. So this is called function calculator. Fine. And what about that expression? So when I click on the expression, you will have by default you have varieties of expression. I'll create my own expressions. For that, just right click, click on new. Maybe you can give any name. In this case, I want to I want to create an expression for a pressure drop. So I'll give a name as a pressure drop. Okay. So once you enter the name, just click on OK. So now a dialog box will be created. So it's more similar to the MATLAB. So MATLAB is an application, you may be heard about that. So we verify that software calculation with a manual calculation, but you can't do the manual calculation by using freehand method. So instead of using that freehand, we use a software called MATLAB. So if you want to work on MATLAB, you have to learn about the Python things. So it's kind of coding. Okay. So I just enter the code. So it's very simple. So first, if you want to insert a function, just right click over here. You'll have 3 options like functions, expression, variables, locations, whatever you want, you just enter. So I need to include a function, the CFD post. So I'll include average, volume average. Okay, so average, and which average? Right click, insert. So a variable, அவங்களுக்கு ஆல்டர்னேட்டிவ் தான் அவர் அவர்கிட்ட கேட்டுங்க. இதெல்லாம் காம நேரம் ஆக முடியாது. இன்னைக்கு தான் எழுதலாம் எடுக்கிறேன். Okay, so which average? So I want to view the pressure average. So the pressure is available in the variable. So go to the variables option. So I'll choose pressure. So now the pressure will be added in that this average. Okay, and also so average pressure at which region? So I want to view the average pressure. Okay, so I will tell you from the first. So once the dialog box is created, just right click, and if you want to include a function, you can just click the function CFD post. In this I want to include the average. So the average factor, I want to find the variable of pressure. Okay, so pressure at which region? So I want to find the pressure at inlet region. Okay, so right click. So the location may be inlet fresh air. Okay, so the velocity inlet fresh air. So the average pressure at velocity inlet fresh air. Okay, so that is what we included here, and just click on apply. So you may get the value of 35.0135 Pascal. Okay, so this is how we use the expression. Okay. So that is all for the session. If you have any doubts, you can ask, or else you can leave the webinar. Any doubts?